So in today's video we'll be talking about the pointers. Pointers are the variables which store the addresses of another variables. So normally variables store values, but the pointer stores the addresses of another variables. Now let's see an example. A value is 4, so this 4 is also a memory address. We are just defining it as a we are naming this location as A so that we can access that value in our code. So it's just for human reference. Now we can get the pointer to this A variable. So let P is equals to ampersand A. So you will get the reference to this I32 value, but this is not actual pointer, this is the reference. So to get the raw pointer you need to cache this as star constant I32. So we have two types of raw pointers. One is constant pointer, this is also called read only pointer, and the next one is mutable pointer, that is star mute I32. The only difference is you can perform operations with the mutable raw pointer. You can change the contents at that pointer using this mutable raw pointer, but with this constant raw pointer you can only read the content. So now you can see we have converted this address of A into a raw pointer. So this I32 means this pointer is pointing to the value I32. Let's also find the actual address of A. Let's first print this value, pointer value. So let's see what is the pointer value by printing the P onto the console. Now here you can see this is the pointer value, and if you go and print star P, so star means we are going to dereference the value, so it means go to that address and fetch the value of I32, that means read 4 bytes at that address. So if you run this you will get the value 4. You can also change this to 8, so you will get the 8 value. So this is called dereference operator. You go to that address and fetch the value of the pointer type. So here the pointer type is I32, so that means go to that address pointed by P and read the 4 bytes. Now let's go and do the operation. Before that we will be printing the address of A. So to do that we can say address of A. So we can do like this. So in the std standard crate we have the pointer and address of macro. We need to pass this A. So this will give you the address of A. Now let's go and print these two values. So these two values should have the same value, the pointer and the address of A. Now you can see we got these both values as same. Okay, now I am going to modify this value. So to do that all I can do is star P is equals to star P plus 10. So star P means go and dereference that value at this address, which is 7, and add 10. You will get the 17 and assign to this value. So this A gets updated to the 17. So this is similar to A is equals to A plus 10. So here you will get error because this is defined as constant. You need to make this as mutable raw pointer, and also we need to make this as mutable reference. So now you can see the error is gone. Now we have changed the value to value of A to 17. If I go and print the value, you should get the value 17 at the end. So here you can see we have successfully changed the value to 17. So this is the pointer arithmetic. and we can also read some contents from this pointer using std pointer read, and here you need to pass the constant of the pointer type. So constant, so if I want to read 4 bytes, I can say I32 ps. Now this value, let's say let temp is equals to, I can go and print this value temp. Now the temp should give me the same value as a, that is 17. So we got the 17. So if I go and change this to 16, I should get only the lower 16 bits. Okay, so I 8. So if you change this to some 260, you will get the lesser value. So here you can see the only the lower 8 bits. So you can change also this value to U8 as well. So it all depends upon this type. The number of bytes we want to read depends upon this type, either U8 or I8 or I32, etc. And we can also write to this pointer. So using this std pointer write, and the destination is p, which is already a mutable pointer to I32, and then we need to specify I32 value, so that is 100. So let's cut this and paste here. Now if we run this, we should get the value 100. So the p is of type star mute I32. So this I32 value only, this second parameter will only accept this I32 value. If it's I16, it will only accept I16 value. So you need to be very careful with the pointer types. Now let me comment out all of this. Now let's see for arrays. So let me let mute b is equals to, let's say 5, 6, 7, 8. So these 4 elements. Now in the same way we can say let p is equals to ampersand mute b as star mute I32. So this will give you the pointer pointing to the starting element of this array, that is 5. And another way to do is we can say b dot as mute pointer. So this is also the same as ampersand mute b as ampersand mute star mute I32. So these both are same. So these arrays have this method as mute pointer to get the mutable raw pointer. Now if I go and read the contents at this pointer, so let's go and print this value. You should get the value 5. So 5. Now if I go, we can do addition operation and subtraction operation for the pointers as well. So what I want to do is I want to p as u size plus 4. So why 4? Because each number here in this array occupies 4 bytes. So I am adding 4 to this and I am converting the final value as mute I32. Now if I go and run this program, I should get the value 6. Now we should see the value 6. So in the same way you can increment this one. So increment to 8, you will get the 7. Increment to 12, you will get the last element. And you can also increment and you will get the junk values, that is whatever the content after this array. So 0. So in this way you can get the pointer to the starting of this array and you can read the contents. And next one is the raw pointers. So let q is equals to this is of pointer I32. So what we can do is b dot as mute pointer, and we can convert this into star mute c underscore void. So for Windows API we will be using this c underscore void in so many parameters. So we are getting this error. You can use std foreign interface and c underscore void. Of course we will be using the Windows API crate, and in that we have also this c void. So we'll be using that c void from the Windows API crate. So this is the raw pointer. So if you print p and q, they will be the same. Now this is about pointers for the arrays. Now let's see the pointers for the vectors. Let me change this to type vector. So the vector of type I32, and this contains 5678. Now if you do like this, ampersand b as star constant you will get the actual vector's address, not the first element's address. Remember, from the vectors, vector is stored in the heap and it contains 3 elements. The first element is the address of an array, and second is the length, and third element is the capacity. So you will be pointing to that address, length and capacities instead of actual pointing to the starting elements. So let's go and read these values. So let's actually run this one and you should see some value. Okay, that is the address of the vector. Okay, let's go and print the actual address of vector also and see whether these two values are matching or not. So copy this address and paste here, b. Now if you run this, we got two different values. Okay, we are actually reading the content. Let's print p value. So let's run this. Now we should get the same value. So you can see the same values. So the pointer is actually pointing to the vector instead of the first element. So how you point to the first element is by using the method. So let q is equals to b dot as mute pointer. So this gives me the pointer to the first element. So if I go and print this one, q pointer q, now we will get the different values. So we got the different value. Now to verify whether this is pointing to this first value, let's go and read the contents at this address. So std read q. So let's print this value. We should get the value 5. So here you can see we got the value 5. And you can also print the length and capacity of the vectors as well. So how you do that is, so read that pointer read that p. So p is pointing to the vector, not the first element. P plus 8. P as u size. Now we are actually reading the length of this vector. We should get the value 4. Now you can see the value is 4. That is the length of this vector. So you can also traverse through these vector elements just like we did this in this array. So that's all for these pointers interest. If you did not understand or follow, just practice one time, and after end of this course we will face a lot of pointers in Windows API functions.